So today's question is 2163, and it is a minimum difference in sums after removal of elements, and it is a hard question. And the question is, you are given a zero indexed integer array nums consisting of 3n elements, and you are allowed to remove any subsequence of element of size exactly uh, n from nums, and the remaining 2n elements will be divided into two equal parts, n and n. First part and their sum would be called as sum first, and the second part will their sum will be sum second. So what we have to do is that we have to find the difference between those, and we have to minimize difference. How we can minimize? So we have to minimize the difference possible between these two. So we'll just see how logic will be. What is the logic behind this question to solve this? So during recording I got like audio error, so I'm voice overing. So here we just got 3 in length array, and we will just okay, so we'll just have to remove n elements, and then we will have 2n elements remaining, and we have to partition between n and n elements. And after this, what we'll do is just sum up the first part and sum up the second part, as it is given in the question that it is sum first and second is sum second, and then we'll have to minimize the difference of both sum first and sum second. So for this, what we'll do is that just increase the sum second because it is the negative one, and minimize the sum first because uh, doing this will minimize the whole part, like sum first minus sum second, because minus sum second we are minimize. So if it is maximum and sum first is minimum, then it will be minimum overall. That is what I am telling. I just got audio error while recording, so we have 2n elements, and we have to divide into n and n elements. So we can consider 2n elements, but we don't have to consider only 2n, because for someone we have to consider someone, and for some 2 it is not. So for some 2 we'll consider 2n, but we'll not do like this. We'll just traverse the whole array, and we'll find out that for this index what is the minimum sum for the prefix, and for every index we will find out the minimum sum for each index, because in the prefix in the sum one we have to consider only the minimum. And for this we will just use priority queue, and for this what we'll do, just we have to consider the n elements. So for that we'll just put in the uh, next element, and we'll just remove the maximum element from the priority queue. That will give you the minimum sum for each prefix index. And we'll the second suffix index, and here we'll traverse from the end, and we'll just do what is that we'll just do the same thing, like using a priority queue. Here we'll use a minimum heap, because it will give you it will pop out the minimum number from your range, and we'll put the next element which is greater than that, and that is what we'll need it, just a maximum sum. And at the end, just we have to do one thing, is that we'll just for each index we'll traverse a prefix and suffix, and we'll check which is giving the minimum of prefix of I minus prefix of means a prefix of I minus and suffix of I, and that is will give you the optimal answer. So that is all about the logic, and we'll code it. I'm in the video telling is that if we consider this index in the prefix and this index the suffix, then in the prefix the beforehand all the elements what the minimum sum is we are getting, that is what I'm saying. And in the second, which is suffix, from that index onwards what is the maximum sum we are getting, and that is, and this will give you the optimal answer after just traversing and updating the minimum of a prefix of I minus suffix of I. So after this let's go for the code, and we'll code it, and this will be optimal answer.
So for the code, what we'll do is just initialize a 3n, and 3n would be the nums dot size, and for the next n would be our n3 by 3, and we don't have to just check for that it is divisible by 3 or not, because if you see here there is given that it is 3 into n, so it is divisible, so don't worry about this. So what we'll do, just I think there no uses of this, but whatever, let's go. So for this what we'll do is just use a priority queue. For the priority queue, why I'm using priority queue, because we have to choose again and again for the minimum and the maximum number which we are removing from the array, and then putting down that which are coming next to the number. So we'll traverse the whole array, like I is equal to 0 to 3 into n I plus plus, and one second. So let me initialize mean and max it. So priority queue for, like, it will be max if, and priority queue it will be your min heap, and for that we have to do this, and this will be your minimum heap. So we'll traverse the whole array. So let's go, and what we have to do is that we have to sum up also now. Let's go. Sum equals to sum 1 equals to 0, and sum 2 equals to, just use sum only now. We don't have to care about all the sums. And another thing we have to do is that we have to sum and we have to put into the prefix and suffix. So there we go, prefix and suffix vector. This will contain your all the thing we have to do. So let's go. What we'll do is that just traverse and put your, so what here we will do is just use our, we have to like popping out which elements minimum or maximum first. In the first half we have to pop out the maximum element and put in minimum element in the sum. So you have to use maximum heap, the max goes into maximum heap your element, that is nums I, and if maxi length, maxi size is greater than n, then just maxi dot pop, and after popping out it will pop out your maximum element from that, and that is good. And here we'll be updating your prefix of I equals to sum, and the sum will be your, okay, so sum here is sum plus nums of I, and whenever we are popping out, then sum will be just to decrease with the maxi dot top element. So this will be like this. And for the next part, means for the suffix part, we can do copy and paste and just go through like this, going from the end to the first, and just do your minimum dot push and sum up with that. First let me do here as sum equals to 0, and then again mini dot size if greater than, then mini top will be removed and mini top will be considered into like minus into the sum, and then the suffix I will be updated for according to the sum, and then at the last what we'll do is that we'll traverse the whole array, that is 3 in I plus plus, and we'll just do one thing, that is we'll have a answer equals to like int max, and we'll just check that if prefix of I is not equals to int max and suffix of I is not equals to int max, then what we'll do is that just we'll update the answer with the minimum of answer comma prefix of I minus prefix minus suffix of I, and that will give you the answer, and we'll just return, and that is it. So let me check it. So it should be running good first of all. So you have to change something, like some you get some errors, then change it, and some condition you have to follow, that if it is an n, then just put it into like condition it should satisfy that if it is of length n, then only just put some, and that should run good. Let me submit it if it is okay. So that's how we solve it, and thank you for watching this video, and comment me if you are getting any error or something.